Hey everyone, welcome. Today we're tackling a fun little string problem from Leetcode called Make Fancy String. We'll break down the problem and look at a couple of great ways to solve it. Let's get started. So here's the official problem statement. You can pause and read it, but don't worry, we're about to break it down into much simpler terms. Okay, so what's the big idea here? The problem defines something called a fancy string. And the rule is super simple. You just can't have three of the same character right next to each other. So for example, 2 A's in a row is totally fine, but 3 A's is a no-go. Our job is to take any input string which might not be fancy and fix it. We do this by deleting characters. The key here is that we have to be efficient. We want to delete the absolute minimum number of characters to get the job done. Let's walk through an example to make this concrete. Imagine the input string is Leetcode. With those 3 E's in a row, we can think about building our result one character at a time. We see loaf, that's fine. The first E is fine. The second E is also fine. Our string is now Lee. But when we get to that third E, we have to stop. Adding it would break the rule. So we simply skip it. Then we continue with T, C, and so on. None of them violate the rule. So our final result is Leetcode. Here's a slightly more complex case. Aber. We keep the first 2 A's. The third A gets skipped. Then AB comes along, which resets everything, giving us A, A, B. Now we see more A's. The first one is fine. We have aber. The second one is also fine. Aber. But now, the next A would be the third in a row. So we skip it. And the A after that would also be a third A in a row. We skip it too. Our final, fancy string, is aber. A quick thought on edge cases. What if the string is really short? Well, if it has 0, 1, or even 2 characters, it's literally impossible to have 3 identical characters in a row. So any string with a length less than 3 is already fancy by definition. We can just return it as is without doing any work. Okay, for our first approach, let's do exactly what we did in the walkthroughs. We'll build a new, clean string from scratch. We'll go through the input string one character at a time, keeping a running count of how many times we've seen the same letter in a row. As long as adding the current character won't push that count to 3, we add it to our result. If it would, we just ignore it and move on. Here's the Python code for that idea. It looks pretty straightforward, but let's break down the main loop on the next slide to see exactly how the logic works. Inside the loop, we first check if the current character is the same as the one we stored as previous. If it is, we just bump up our frequency counter. If it's a new character, we update our previous variable and, importantly, reset the frequency back to 1. The most critical part is that final if check. After we've figured out the frequency, we check if it's less than 3. If it is, we're safe to add the character to our answer string. Alright, approach 2 is a little more clever. It's a common and powerful technique, often called a two-pointer or in-place method. Instead of building a totally new string in a separate variable, we'll try to modify the input string itself. The idea is to keep a pointer, let's call it J, that marks where the next valid character should be written. Before we write a character, we just look back at the last 2 characters we already wrote to see if this new one would create a forbidden trio. And here's the code for the two-pointer approach. You can see it starts by handling that edge case for short strings. Then, it converts the string to a list, because strings in Python can't be changed in place. The real magic happens in that loop. Let's focus on this key condition, because it's the heart of the solution. J is our write position, and I is our read position. We are considering whether to keep the character at index I. To decide, we check it against the characters at J-1 and J-2. Which are the last 2 valid characters we've already approved and written. If the current character is different from either of them, it can't possibly form a sequence of 3. So if that condition is true, we copy the character to our write position and move the write pointer forward. So how do these 2 approaches compare? Well, in terms of time, they're both great. Each one looks at every character in the string just once, so we call that big O of n time, where n is the string's length. For space, it's a bit nuanced. The first approach clearly uses big O of n space, because it has to build a completely new answer string that could be as long as the original. The second approach, in languages like C++, could be big O of 1 or constant space. But in Python, because we have to convert the string to a list first, and then join it back, it also effectively uses big O of n space in the end. So let's wrap this up. We tackled the make fancy string problem, and the core rule was easy to grasp. No three-peats. We saw 2 solid ways to solve it. The first was a very direct and intuitive method, building a result string from scratch while using a counter. The second was a common and efficient pattern using 2 pointers to modify the string, checking against the last 2 valid characters. Both are great solutions. I hope this explanation was helpful. If you learned something, a like or a subscribe would be amazing. Feel free to ask any questions in the comments below. And you know I'm always powered by Boba. Thanks for watching, and happy coding!